Okay, so I'm Paul Nieberding. I'm with Fondriest Environmental, and I'm going to be talking about high accuracy mapping with Bluetooth GPS receivers. And it's going to go into more than just that. I did bring one Bluetooth receiver with me, so it's about palm size, as you can see. It's got a lithium battery pack back here, all the receiver components, serial, USB, and RF cable for the antenna. So I'll pass this around during the presentation so you guys can take a look at it. Feel free to turn it on. There's not much you can do besides that, but just to give you an idea of what it is, how it works. So a little bit about the company. So we're in Fairborn, Ohio, which is kind of east of Dayton, close to Wright-Patterson Air Force Base. We've been in business since around 2000, so about 15 years now. We, as I mentioned earlier, we're a supplier of a few different GPS receivers. Both happen to be located in Canada. The one we're passing around here is manufactured by Geneq. They're in Quebec, so we got the little French connotation to it. That's the SX Blue series. That one there is compatible with iOS, Android, Windows Mobile. So it will work with just about any data collector software program. We also distribute rugged handheld computers from Trimble, like the Nomad, the Recons, the Umas. We also distribute handhelds from Juniper Systems and a company called Cedar Tree that makes rugged Android computers. The internal GPS on those computers is just like a 3-meter accuracy. So generally that's coupled with something that's more accurate because people need more than just 1 to 3 meter accuracy. So as part of the presentation, I'm kind of just going into what are the considerations when you're buying a GPS like software solution, just kind of a total package. So starting with the budget, you've got to figure out what you want, how much you want to spend with this, not just on the receiver, but the software, the training, the maintenance, things like that. What do you want the system to accomplish? Obviously, there's different software programs for different applications. Software is typically the critical component. People call asking about the hardware. They also ask for software recommendations, and I always tell them to start with the software, research what software is going to work best for you, and then figure out which data collector is compatible with that software, and then the receiver is compatible with just about anything. So that's typically the easiest choice of it all. The GNSS receiver and technology, it's constantly changing and improving. I know both the European and the Chinese satellite constellations are something that people can utilize as well in the near future. Right now, that one uses the SBAS and the GLONASS satellite constellation, but you'll be able to access more than just those satellites as they come online. And then training and maintenance is another thing we'll go into a little bit. So budget-wise, there's really no use in requesting an SUV if you can only afford a compact. So you got to be realistic with what you're asking for, what you can spend not only upfront but then also on any annual or monthly maintenance costs. The cost and system complexity are generally directly related to each other. So the more complex, the more expensive it gets. And so it's not just the receiver, it's not just the software, it's the receiver, the data collector, the software, the training, the maintenance, and that equals total cost of ownership. So what are the ranges? GPS receivers can range anywhere from $200 to $10,000. You mentioned you use Trimble equipment, so I know they have affordable options. They have $10,000 options. Handheld data collectors, anything from a smartphone to a rugged tablet computer, can be up to $3,000 plus. Data collection software. Sometimes you can still get the one-time purchase software, but anymore it seems like there's a monthly or an annual maintenance or fee associated with that software. Annual maintenance depends on the manufacturer, and training is generally negotiable. Typically, most of the training is on the software side of things. So the system definition, what type of data do you want to collect? That's going to determine the data collection software that you want to pick out. We don't deal much in the software, so I can't speak to many recommendations on that. It's mostly the hardware that we deal with. But one thing, if you're trying to input other sensors, there's laser rangefinders that will integrate with different software programs, digital cameras. If you're doing work on the water and you want to use an echo sounder to measure distance to bottom for bathymetry applications, video cameras, there's quite a few additional input devices you can use. Which operating system do you want to use? So Windows, Windows Mobile, Android, iOS. Those are the big ones that I mentioned that the receiver I'm passing around. Those are the compatibility options there. So more and more we're seeing the iOS and Android apps coming online and people using that. Screen size is another one. I know some people use an iPhone-sized device with their data collection, but a lot of people prefer like an iPad size, more real estate to work with. If you need a keyboard, that's another, some data collectors have an integrated keyboard, some are virtual keyboards. It comes down to personal preference there. Ergonomics is another one. And then ruggedness, if you're going to be working in or near water, you generally want something that's waterproof or water resistant. If it's more light duty, you may not need that, and you can get a more affordable data collector. So as I mentioned, software ranges from free to more than $1,000 a copy. It's operating system dependent, so there's programs out there that only work on Windows Mobile, some only work on Windows. So that's why you want to kind of start with what software is going to work best for your needs. And then the data collector and receiver can come next. And if you're part of a larger organization, some organizations may already have a license of ArcPad or GIS that you can utilize or at least get bundled in, at a more affordable rate. You can see there a few different software options just to give you an idea of what's out there. And then I listed some here. So we have ArcPad, TDS Solo, Digiterra Explorer. You can see the list there. I don't have to read them all off to you. Some are vendor dependent. So Trimble TerraSync generally only will work with Trimble devices, and they kind of lock you into that, which has worked. It's a business model for them, has worked for some time, but more and more we're seeing a device that's independent of the software and the data collector. It just seems to make more sense because when your computer, once that becomes obsolete, you don't want your receiver to become obsolete. So having them separate kind of future-proofs itself. So we'll go into the accuracy levels of the different equipment out there a little bit, talk about tree canopy obstructions and how that affects the accuracy. And then we'll talk a little bit more about smartphones, some of the receivers that we offer. So I've listed out some of the different accuracy levels here. 2 to 5 meters plus is generally what you see in the consumer grade GPS. 2 to 5 meters is kind of entry level. 1 to 3 is, you're getting into the GIS. Sub-meter, the receiver I passed around is sub-meter. That's a 60 centimeter accuracy receiver. Get into the sub-foot. Generally, you're connecting to a RTK or DRS network to get your real-time corrections at that point, and then centimeter level with RTK networks or creating your own RTK network. So here's a few different low-end consumer GPS that have the 2 to 5 plus meters. You see some Garmin devices, your smartphones, those generally have the low-end receivers and antennas, which, if you're just using it for, when you're driving with your smartphone, you don't need a high accuracy GPS because there's algorithms built in that know you're on the road or you're on a different road. It assumes you're on a road though. See some of the 2 to 5 meter accuracy GPSs here. One thing is you can do post-processing to improve that, but again, then you're using software and spending time in post-processing anymore. If you can get the real-time sub-meter accuracy, it's going to just save you time sitting at your desk correcting your data. Here are a couple 1 to 3 meter accuracy GPS receivers. This one here actually just has a lightning connector and plugs into the bottom of an iPad or iPhone. It's made by a company called Bad Elf, and they're just $100 or $200. So it takes the 2 to 5 plus meter accuracy of your iPad or iPhone and improves it to about 1 to 3 meters, if that's all the accuracy that you would need. Then we get into the sub-meter. This is the one I'm passing around here, the SX Blue 2. This is the Aero GPS. They look very similar. They were actually invented by the same person, so there's a lot of the same characteristics in there. The person who came out with the SX Blue line from Geneq left the company and started this Aero company. So I think moving forward, the Aero receiver is probably going to have a few of the more features and functions because all the talent is now there instead of at Geneq. You get into the subfoot, good hashtag top con tremble. This one here, this Aero device that I just mentioned, you can connect that to like the Ohio VRS network through an internet connection and get real-time 10 centimeter accuracy. So it's about a $3,000 receiver that gets you 10 centimeter accuracy. So it's a pretty affordable solution. And then you can get to the centimeter level. This here, what I did is I listed out all the components you would need with that receiver to get centimeter level accuracy. So you have the receiver, the L1, L2 GPS receiver. That's about $6,000. You need a data collector. It could be your existing smartphone or iPad. So again, something you might already have, pretty affordable. Software could be free, could be paid. You could already have it. Connection to the ODOT VRS network. I'm sure a lot of you are familiar with that. But Ohio Department of Transportation has what they call the VRS network, where you can get a free subscription and they stream real-time corrections to your device. And they don't charge for it. A lot of states do charge for it. Probably half the states in the United States do charge. Some don't have any RTK networks. So it just depends. We're kind of fortunate to have this. Now, the last component there to get those real-time corrections is an internet connection. So if you have a Verizon Air Card or something, to get those while you're working in the field, that's great. But then when you get into a situation where there's no cellular connection, you lose your RTK corrections and you're back to 60 centimeter accuracy. So if you need centimeter accuracy all the time, then you're back to creating your own RTK network using hardware on the ground and radios to transmit those coordinates. So this is kind of a virtual RTK network where the infrastructure is there, you're just getting those corrections through the internet. So a little bit about tree canopy and obstructions. All receivers are negatively impacted by tree canopy. There's no silver bullet or magic receiver that's going to work well in those situations. It degrades considerably, considering how the severity of the canopy. So some receivers have built-in algorithms to help with that. This one I'm passing around. If you go into a tree canopy situation and you lose that differential correction, it'll still get you sub-meter coordinates for up to 40 minutes before it goes dark. So it just has those built-in algorithms to kind of know where it's at. So some are designed to operate optimally, some are not. So with medium quality receivers, your horizontal error is about 3 times, and under heavy canopy, it could be 3 times more than that. So it could really, really affect it. And consumer grade receivers are very unpredictable in those situations, so not very useful. So then we talk about the all-in-one for simplicity, or the standalone for flexibility. You can see here some of the all-in-one solutions. It packs the data collector and the receiver into one unit, which is great from a simple standpoint. You just have one thing you're carrying out there. But when that software or when that operating system becomes obsolete, or the hardware is so old that you can't install anything on it, then you're spending $8,000, $9,000, $10,000 to replace that. Whereas with a standalone unit, you have your receiver, you have your data collector, and then the software. And that gives you a lot of flexibility. Let's say half your staff uses Android, half your staff uses iOS. Well, you just need one receiver, and they can share that throughout the group. So it just gives you a lot of options as far as what you're going to use to get your data. You probably can't see much of this, but the SX Blue series has quite a few different receiver options. A few here, these are externally powered. If you're putting it in a vehicle and you're always going to have 12-volt power, you can save some money by not getting the internal battery. A couple of these here are more affordable and not compatible with iOS. So Apple has this rigorous certification program for you to work with their Bluetooth. So that's one where these devices have gone through that, and as a result, you pay a premium for that. So if you don't need iOS compatibility, you save a little bit of money. So they have some of the just the L1 receivers, which are sub-meter, and then some of the L1, L2 receivers, which get you the centimeter accuracy when used with an RTK network. And then the Aero receivers, which I didn't bring one with me. I didn't have one to bring along, but there's only 3 flavors of it. There's single frequency that just uses GPS for corrections. That's about $2,000. There's a single frequency multi-constellation, so it supports not only GPS but GLONASS, and then the European and Chinese constellations once they're online. So they'll let you use up to 3 satellite constellations at one time. And that one's $3,000. And the Aero 200 is the L1, L2 receiver, which allows you to get centimeter accuracy when used with an RTK network, and that one's about $6,000. So battery life, you get 16, 12, 8.5 hours, so pretty much a full day of use on with one receiver. They're all iOS compatible, along with Android, Windows Mobile. So, and I don't know if you saw, there's a button or a light indicators on the side of it, so you turn it on, you know it's on. You know when you're connected to the differential corrections, you know basically what accuracy level you're at just by taking a quick look at the lights. So smartphones, I mentioned, they generally use inferior GPS receivers, and typically the antennas are pretty inferior as well. Any more smartphones, they used to make the receiver inaccessible to third-party software. Now it's pretty much wide open, so any iOS device or Android device, you can get that connected up. And many new smartphones now have the processing power to run these programs. I know Esri has the collector app. Does anybody use a collector app at all? Yep, so you're familiar with that.
I just have a quick question.
Yeah, sure.
So you're saying like smartphones generally use inferior GPS receivers. So what about those apps like the collector app you just mentioned?
Yeah, so if you are using the collector app with your iPhone or iPad and nothing else, it's 2 to 5 meters plus accuracy. Now, if you connect up that to it, then it's using that receiver rather than the internal receiver. So that takes your 2 to 5 meter accuracy and makes it sub-meter.
Just fine. Still use that app.
Oh yeah, absolutely. Yep. Yep. So the way it would work is once you're connected up, it overrides the internal receiver and only uses that. So it's basically streaming that through Bluetooth. There's no cabled connection or anything.
Awesome.
Okay. So you can see a couple smartphones, tablets, and pretty much anything has a built-in GPS anymore, it seems. So everything's trending toward high accuracy GIS collection because the technology is improving, the cost is decreasing. You can put that receiver, you can put the antenna, put everything on a range pole if you're using a range pole. This comes with it, so it's got a little belt clip. You can put this on your belt, and there's even a ball cap. You can put that antenna in your hat if you don't want to use a range pole. You want to use yourself as the location. So you have a lot of options, and it's not that bulky. I mean, you have to have a cable and you have to have an antenna, but there's not much to it. So training and maintenance. Most of the training is going to be in the software. There's not much training involved with this. You turn it on, you pair it with your pair it in iOS and set it in the Bluetooth settings and connect up to it. And collector, you don't even have to specify which GPS you're using. You just have to make sure that it's connected through the Bluetooth settings and it's using that from that on. So. Okay. Really, on something like that, there's not a lot of maintenance other than if the battery goes dead, you have to, if you charge it and recharge it and recharge it, after a couple of years, that battery is going to stop holding a charge, and that's something that you would need to replace. But that's just swaps right out, and you can buy spare batteries if and as needed. So my contact information is there, website's there. There's pricing on all these receivers on our websites. We also distribute a lot of water quality and environmental instrumentation. I heard a few of you say that you worked with the water department or water groups. So if you do any water quality or water level, we do a lot of that as well. But does anyone have any questions? Yes.
So I was doing this. So there's different agencies you're going to need, for different types of agencies you're going to need like a different level of accuracy. But who are you seeing in like the public realm that's getting these very high accuracy receivers as opposed to
public? It's generally the 60 centimeter accuracy. They want the sub-meter.
Okay.
I don't know offhand of a lot of public customers that are buying the $6,000 receivers for the centimeter accuracy. Generally, those are surveyors and people who really need that centimeter level accuracy. That's really popular with utilities, for finding different things and meters and just things like that. If they only need sub-meter accuracy, turn it on, plug it in, we're ready to go. So.
Okay. I think water is 36 centimeters. Be accurate. 36. So we'd probably need, if you had an internet connection and set Arrow 100, you get 10 centimeter accuracy through your ODOT network. So, for $3,000, that would get you 10 centimeter accuracy. This is they spec it at 95%, 60 centimeter accuracy. But I've heard customers say I'm getting 30 centimeter accuracy, but it's not all the time. I mean, it's in a very open sky, clear day type situation. So, and you have the accuracy estimate that on the. I think does collector support the accuracy field? I don't know if they do or not yet, but I think they do. It's when I look at it briefly, you can adjust what kind of accuracy you want.
Okay.
And one of those down to like some ridiculously large.
Yeah, I'm gonna say it's
20 feet or something like that.
Yeah, right. And I know I talked with the manufacturers of these devices, and they said that the hardware is there. It's just a matter of the app companies catching up with the capabilities of the hardware, because even like Esri, they have the apps and they continue to put these different features and functions into the apps, but there's a lot that the hardware manufacturers wish they would have that they don't have, and they say they're working on it. So it'll be there soon. Both these receiver companies have their own iOS program, just so you can connect up, see how many satellites are in view, see what the accuracy is, just kind of a configuration app, but it doesn't do any mapping or data collection. It's just more a diagnostic tool. Any questions?
Is there a secret to connecting up to this or by the
Yes.
not doing the right thing? I got it to pair, hey,
We got it paired, okay.
but it's not, it doesn't want to,
Let's move it towards, close to the window. It's gotta be,
You can stay there.
oh, I guess that's right.
I was gonna ask, how far can you be from that for it to connect?
Actually 1,000 feet. As a Bluetooth spec, yeah, so it used to be 30 to 60 feet, but they put a better Bluetooth antenna in there, so now it's 1,000 feet. So that's one thing. If you have the data collector in your vehicle and you want to, have your partner go out and collect all the data.
Yeah, you can see here, this, my phone is 3 feet.